kind of like last time, I'd like to talk about our networking topic. And this time we'll actually do a sampler or two before we break, and I'll give you time then to work on your group project. Thursday, we'll do the same kind of thing. We'll talk a little bit about stuff and then have the majority of time for working on things. This week, it's not just your group project, though, that's due. There is a chat program that can be quite challenging, also due, so that's why I'll be giving you some extra lab time, or hopefully enough. So let's talk about networking overall first, because it's a concept that some of you might be super familiar with, and some of you might not really have much background in networking at all. But you all use the network, right? You're super effective network users. You know how to get on and make things work. And probably, if you're like students I had when I taught networking, you know how to click that option that tells Windows to test for your problem that messes up your network forever. Don't click on that. All right, but what do we need to know about networking for programming? Some of the same concepts, really, because if we're writing a program behind the scenes that takes advantage of the network, we need to know how the network is set up. And this is from what? Weeds? Is it from Weeds? It was like Weeds, but actually it's a network. So it's a network of tiny houses, right? So all of these houses belong to the same network. They're all in the same neighborhood. If I was looking at this house and this house, they're both kind of white. They both have light colored roofs. Could I give them the same address if I wanted to? No? What would happen if they had the same address?
So it would confuse delivery folks.
It would confuse delivery folks. Who else would it confuse? Fire trucks, police cars, all of those kinds of things. So whenever we're working with a network, whether it's a network of homes in a neighborhood or a city or a country, or whether it's a network of computers in a classroom, everything has to have a unique address. This is really important. Whenever we look at an IP address, an internet protocol address, which is the address that we see being assigned to computers and to hosts across the internet, those IP addresses must be unique across the internet, period. They cannot duplicate each other. We use currently IPv4, version 4 of the IP addressing scheme. So when we write our programs, we'll be looking at those format IP addresses. Those type IP addresses are comprised of 4 numbers separated by dots. That's called dotted decimal. Dotted decimal notation because we have a decimal number separated by the dots. The numbers between those dots can be between 0 and 255. We will never see anything bigger than 255 because that's an 8-bit number, so it can't get any bigger. Whenever we are working with a network, those IP addresses would not be helpful to us to find things. So if I wanted to, I could find Google's IP address, 123 dot whatever, and I could remember that and I could type that in anytime I wanted to bring up Google's website, and that would be fine. But that wouldn't be very easy to remember. We do that, or used to do that with phone numbers, but now with cell phones, sometimes we don't even know the phone numbers of our family because numbers are hard to remember. We don't do good with that. I used to have a student that could kind of do those party tricks. If you guys had friends like that, if you showed him a credit card at the beginning of class, just showed it to him, here it is, Chris, like that. By the end of class, he would still be able to repeat what all of those numbers were to you because he had one of those kinds of minds. But that's unusual. That's why it was a party trick, because most people can't do that. And so he could amaze people with his abilities. We don't do good with numbers. We are not those kinds of brains. So we have domain names. Domain names give us a way to assign a logical name to a network, to a group of computers. When I'm working with a domain, I have a domain name server somewhere that stores all this information, and it keeps a cross-reference table for me of domain names to IP addresses. So my DNS server is one of those configuration parameters you may have to set when you first got on the internet so that it can find that domain name to IP address mapping. Domain names have a structure. Whenever we are looking at that top level domain qualifier, it's always going to be meaningful. So this one, this domain name is ru.wikipedia.org, and it shows you how the domain name server system finds that lowest level item, and then it keeps working its way up till it finds the top level domain, the TLD. The TLD is actually defined within a database that exists controlled by the government, and that top level domain database lists every .com or every .org type URL that there is. So they all have to be registered. They can't just be dynamically created. All right, so those are things we're going to be looking at when we start creating some networking programs. Why? We need to know what kind of IP address the computer that we're going to connect to has. We need to know what its IP address is and all those wonderful things. So let me see if I can find, I might have too many things open. So let's write a program that lets us bring up the information about a network. Some other things about networking. Whenever we're working with different services, we think of a client and a server. And I think you guys are very, very understanding of that concept, that if my computer is asking for services, it's a client. If it's supplying services, it's a server. So my computer can be both. I can be a client and a server. The request that I'm making or the request that I'm fulfilling determines whether or not I'm a client or a server. Whenever we want to communicate between two different machines with different IP addresses, we use what's called a port number or a socket. So you guys probably are pretty familiar with the fact that HTTP runs on port 80, so that's usually not blocked. So if I'm trying to get something through that's using a blocked port, sometimes I can trick it to use port 80 to get through that unblocked port. The port defines the application. So I basically have an IP address that defines the machine. I know what machine I want to get to. And then I have an application running on that machine that's usually defined by the port number or socket, as we refer to it. So if I'm a server, what I need to do is on my computer, on my machine, open a socket somewhere. Now I have this open connection. It's just like a bunch of wires or like an outlet on the wall. It's sitting there ready. It's ready for something to plug into it. My outlet on the wall can be sitting there forever without ever having anything plugged into it, or I could plug something into it. That's how my server socket's going to be. It's going to be an open port sitting on this machine, just waiting for someone to come and connect to it and do some work. So on our server, we'll open the port, and on the client, we'll connect to it. So let's see if we can do that. We're going to start with a couple of different things here. Let me get to the right place. I think that in this one I want to skip a little bit. Yeah, here we go. Okay, let's create a new project. And I want to name this project is going to be listing 31.3. So not the first one. Come back to that. Now, as far as creating a main class, I do want to create a main class, and I'm going to call it identify host name IP. You don't have to make yours that super long, but They're trying to be descriptive for us of what this thing is doing. Finally, it just wouldn't cooperate. All right, now before we can do any networking stuff, we need to import the library java.net. And we're going to get everything from the java.net library. And in our main for this one, we're just going to try to gather some information. So let's set up a for loop. It's cleaned up. And in our for loop, we're going to use an integer named I and start with it equal to 0. Now for this one, we're going to use the args, you know, those input parameters that are always up there in our main. So that'll be a nice thing. I know we've used them before, but it's been a little while. It may not have been this class. It might have been the Java 1 class. So it'll be good practice for us. Now, in my for loop, I'm going to execute while I have args, meaning as long as I have arguments that have been passed to my program at runtime, I'm going to process them. So in this for loop, we're going to do a try. Networks, you know, are very unreliable. So whenever we're working with networking commands, we should always have our commands enclosed within try-catch type code, so because we should be expecting problems. Now for this very first one, we're going to use the inetaddr class. It's not liking it for me. Liking it for you, even with our import here.
Yeah, to make it instance of it like with there.
No, we shouldn't have to.
I'm not there yet. I'm not having errors yet.
I'm going to put that in. Let's see what. Oh, I see it. So the reason that we're running into problems right away, the INET address, the internet address, has actually some different names now. I do see INET address, so I should be being able to do that. I'm going to import that directly. But notice that we could be using IPv4 or IPv6. So whichever is appropriate for you, those different options exist. I'm going to go ahead and just import INET address because it should be able to handle both types. So is it just mad at me because I'm in this try? I might just have to not worry about this try for a moment. What? And then it'll quit griping at us. Whenever we're using this INET address utility class, we're going to use the get by name method. And the name that we're going to want to get has been supplied to us as an argument. So we use our args. Once I've gotten that address, I'm going to output host name. And then I want to add address dot get host name. Output a little bit more. IP address. And we'll add address dot get host address. Now, after my try, I want to catch, and I want to catch unknown host exception as an exception object named EX. And if that happens, I'm going to do system.err.println to go right out to the error console instead of the regular console. Unknown host or IP address. And then we want to output the host name that was passed to us with our args. Clean up some stuff here. Now we want to set those command line arguments to run so we can use our configuration. Up here where it says default config, if you click the down arrow and choose customize, this run screen right here has a place for our arguments. They had some suggestions before, but I don't remember what they are. Let's find some. The one I want to try first is 127.0.0.1. Let's see if we can find any others. I'm doing it wrong. Okay, there's Google, so I'll use that IP address. 172.217.6.14. So we can put out as many arguments, command line arguments as we want in our arguments parameter for our run, and then it'll save those for us. So when I click OK, I should be able to run my program. But I right-clicked and did run, so did it use my arguments that I'd saved? You got what?
The unknown host or IP.
So it did something, huh? So I'm going to check my default configuration, my customize. It's got it all here. So I'm just going to have to use this run command maybe at the top. Use my arguments. There it did. Now my output is a little different. So I did get it to use my arguments by just using the run button up here. So when I've changed this default configuration, if I right click and do run file, it's not using that. But if I save it and then use my run button up here, it is using it. Now it said it couldn't find 127.0.0.1. That's okay, because 127.0.0.1 is always the local host. So that's your machine. So yeah, when it went out on the internet and tried to find it, it was like, no, there is no such thing, which makes sense because every computer has that IP address internally. But then it found Google. It said, oh, 172.217.6.14 is this really weird host name, because Google likes to have weird host names. Can we find OTC? Let's see. Yes, sir? You want me to get rid of it? Does that work? Does it find it? I want to see it. So do you just leave it as space? I never mess with it. All right. There it is. It didn't say much, right? Host name and IP address are the same because it's always our own local machine.
Good little tidbit there.
Yep. That's why those nerd shirts say 127. There's no place like 127.0.0.1. Means there's no place like home. I love the nerd shirts. Okay, so I'm going to put in OTC's IP address. Let's put one in there. I want to go back to my configuration and let's put in OTC's is 198.209.160.18. And then you should see that third one being OTC. So this is just a nice utility that we can use to get information about the network, about local hosts or network hosts that we want to communicate with. So helpful for us because we can gather some information about things. So now let's see if we could create a client and a server ourselves. The first thing we want to do is create a server. So let's create a new project. Now, when we're creating this client server stuff, you have so many different options for how to set it up, right? Because you could set up your server is one project and your client is another. You could set that up one project that has the client and the server process both in it. So you just have all these options. Don't feel like you're stuck doing it one way. Whatever makes sense to you is just the perfect way to try it. We could actually have everything all in one class, but it wouldn't work very well. But with a client and a server, we can have it separated however we want. For this particular one, I'm going to create a new project. And I'm going to name this one listing 31_1. And I want our main class to be named server. This will create our server class for us. Now our server, if you remember, needs to open this socket. So it needs to decide, I'm going to communicate at this certain port number, and I'm going to open a socket at that port number and just sit there waiting for someone to come connect with me. So we could make it open this socket on whatever port we like, but we could run into problems with blocking because every firewall in the world is going to do port blocking. So we always have to be careful when we're networking to remember that we might not be able to do things because of firewalls and things like that. So I might be able to get my client and server to run fine on this machine, but if I tried to connect them across machines, I might have trouble because of the firewall. I might have trouble because it's more complicated. So it's the kind of thing that requires a really pristine test environment that we don't have. So we would have to make sure that our network people were not blocking things. All right, so for this application, we're going to make it be a JavaFX application. It's going to be a little bit like a chat, only it's going to be unidirectional. It's not going to go both directions. So we need to do some imports. We're going to actually have quite a few. You want java.io.star, java.net.star, java.util.date, application.application, application.platform. I messed it up again. Scene.scene. Scene.control. Scroll pane. Scene.control.text area. And stage.stage. Now in our server, we're going to be extending the application class because we want it to be a JavaFX application. So I'll use our @ override to override that start method. Remember, our start method gets a stage. And we'll call it primary stage. Let's create a class level field to display our contents. So we want our text to be available across this class. We're going to create a text area called TA. Our new text area. Now let's create our scene. It's going to be a new scene. And in this scene, we want to add a new scroll pane. Remember, it's going to be an anonymous scroll pane since we didn't name it, but it's going to hold our text area, and then we're going to give it some dimensions. Go ahead and set our title on our stage. Server. We'll set our scene, be our scene, and then we'll show our stage. So awesome, we've got our stage showing. Now we need to do some things to create our server socket. So after we've got our stage showing, let's create a new instance of a thread. Now this is going to use some Lambda syntax. So we want 2 opening parentheses, 1 closing parenthesis, followed by the Lambda arrow and an opening curly brace. Now the next line down, we want to start with a try. Again, we're networking, so we're always going to embed within a try. We're going to create our server socket. We're going to use the server socket class to create that socket, and we're going to name it server socket. So we're going to try to just be as simple as we can here because we're doing some pretty advanced stuff. And we're going to say this is a new server socket, and I want it to run on port 8000. Now, is that an open port? Well, I could go look, TCP port 8000. It's not. It's actually, let's see what they say. I'll go to the terrible, terrible Wikipedia. Notice that all of the ports here are declared and defined. And if we scroll way down, 8,000 is actually not that high of a port. 15,000 and above are considered high ports. They're always blocked. I could do a find. So 8,000 is highlighted here as something special. It says it's commonly used for internet radio streams like Shoutcast and iTunes Radio. It looks like we could have trouble if we were using DynamoDB or this, how do you say that? Jenga. So that could cause us trouble because it normally runs on port 8,000. So no big deal, we could just change it to a different port number, but always be aware that you could have those conflicts like that on whatever port you're trying to use. We want to make sure that we're always on an open port. I lost my thing. I'm not sure how, but I will go find it again. So we've decided that we're going to be using port 8000. We're going to use that run later command that you saw in your assignment for this week. Now, if you didn't see that run later command in your assignment for this week, go back and double check that case study in chapter 30 because we need the run later. What does run later do? Somebody tell me.
Runs it later.
Yeah, that's good. Later than what? Later than now. Remember, excuse me, when we were looking at the picture of all of the penguins that were trying to share the processor when we were doing multi-threading, we said that we had the opportunity to use the processor whenever it became free. That's what the run later statement is saying, is put me in line because I don't want to run right now. I'm not ready. But as soon as a thread releases control of the processor, I would like to run later, run then. So part of our multi-processing package capability. So we're saying we'd want to run later. And what do we want to run later? Well, we want to update our GUI by adding this text to our text area. And we're going to say server started at whatever the date is right now. Bless you. That one should actually be part of that line. Let me put it back. There we go. Like that. So our run later command is just being issued to update our GUI display. So as soon as there's an opportunity, it's going to update it with that message. Now, our socket is going to sit here and basically kind of be in an infinite loop. So it's going to listen for a connection request. We have to tell it to listen, to say, go ahead and create a socket. That socket should be named socket. And we want to use the server socket class accept method, accept a connection request. So it's just going to be sitting there running for as long as that takes. Now, if we do receive a request, we're going to create data input and output streams. So just a nice path for us to send data back and forth between the two machines. We're going to create a data input stream, and we're going to call it input from client. Now, this data input stream that we're creating has to be associated with a socket. On our server, we could have 50 open sockets, right? 50 different connections open, waiting for communication. For us, we only have this one, so we can specify that our data input stream should be looking at our socket, and we want to do the get input stream on our socket. Let me fix that a little bit. Have it kind of messy. Now that's good for our input. We need to do the same thing for output. Data output stream, output to client, and it's going to be a new data output stream. And we'll make it dependent on our same socket and using the get output stream method. Okay, so we sat there listening, running this server socket.accept. It's just sitting there in a loop waiting. As soon as we finally get a request, we're going to allocate this input and output streams. And then we're going to really go into an infinite loop. For this example, we're going to receive a radius value, the size of a circle, from the client. We know it's going to be a double. So when you guys are creating your chat, you're not going to be looking for a double. So you'll have to be using something a little different. Now, once we've received that double, we can compute the area. We'll create a variable called area. And we'll say that is radius times radius times math.pi. So now that we got this calculation done, we're going to send it. We want to output it to our client by writing a double. Now, if you notice this list, there are lots of different formats to write and read things in your stream. And what we want to write as a double is that area field. Okay, still within our while true, we're going to do another run later. Platform.run later. Now, what we want to run later is an update to our text. So we're going to append text, and we're going to add this string radius received from client. Plus our radius. And then let's go ahead and send a new line. Then let's add a little bit more. Area is our area. Okay, I need to clean up some ending things here. My closing parenthesis here should come after my closing curly brace for my run later. And I want to put a semicolon after that. I'll label it end of lambda run later. Here's the end of our while loop that's never going to end. End of our try, which is super important because that's where we're going to put our catch. Then I've got this right here needs to kick off our start method. This will be the end of our start method. So we need to add our catch. I'm going to put it right after this end of try, closing curly brace. And for this catch, we're going to be looking for an IO exception. We'll call it EX again if we receive one. And if we receive one, we're going to use the exception to print the stack trace. I don't know what that'll show us. It'll show us where we've been, and that should help. Okay, so now in our main, I'm going to put the launch. Cat. If you're ready, you should be able to try it. See if I can do it.
Windows Firewall has blocked.
Ah, no. We've always been able to do it.
It still has something behind it. The server started.
It does say it started.
Yeah.
I'm not getting mine. See if I can get a window here of anything. I'm not getting any messages. Oh, there it is. I could allow access. It wouldn't do me much good, would it?
It's up to the.
It gives you the password
It gives
screen.
you the password.
Okay, so it thinks it started, so that's good. Is everybody's got a server started message?
I've got it. I'm messed up.
Did you what? You got it? You want to do our client? Make a client connect to it.
I'm messed up somewhere. Curly.
You got a curly brace problem? Let's fix you up because we want to try a client again. Let's see if we can fix it.
I think it's messed up. It's been busy there.
Oh. No, can't see. Sorry. Can't see. It's just a try. Okay. So what is the time? Two open, one closed. Two closed.
label as soon as I write it back. So I know what it's supposed to be for. With the airfare stuff. It's a spec. Unless you got 6 grand. Because it's expensive. It's not set up to do a room.
No, that should be okay.
Yeah, my bill. Oh, which one? No, I can't. I'm off in another world. So. 4 computer languages, 3 projects.
They said they were gonna let us know in April.
No, I hadn't heard.
I haven't heard anything either. And every time I email them, it's still on. They had a tweet one of the six. Said they got it. So I told them to get it.
I don't even remember. I don't even remember. I got it. What the weekend was. Yeah. So it was just after the trial.
Wow.
But I forgot I said that. Here. Most of the I have no idea. You're the only one I heard that really shocked it, so I don't know. And we get back in there and return to our oh, you're not extending that. And work on sale and an extra time. Yeah, it's expensive. I wish I had
Okay, let's make our client be a separate project. So our client, let's create a new project. And we're going to name it listing 31_2. Now our main class is going to be client. Listing 31_2 client. See if I can do it without making any more typos. Okay, for our client now, I'd like to be able to maybe copy some things. So the first thing I want to do is copy all of these import statements from our server. So let's copy those. IO, net, application dot application. Okay, a couple of things to add. We need JavaFX dot geometry dot insets and geometry dot POS. We've got scene. Okay, we need to add some more controls. Scroll pane is good. Text area is good. We need to add label. And text area, or text field, sorry. We already have text area. Text field. And then we need to add JavaFX.scene.layout.border pane. That should be all that we need. Now our client is also going to extend application. We want this to be a JavaFX app also. Now for our client, we don't need necessarily to have that text area as a class level field that we can access everywhere, but we do want our IO streams fields to be so. So we have data output stream to server. We're going to set that right now as null. And then we're going to have our data input stream from server also equal as null. Now notice when you're working with these how it's really hard to name these streams a very accurate name and not get confused when you're working with them, because no matter what you do, there's going to be times when it's a confusing point. So in our server application, we named it output to client, and in our client app, we'll be reading that data using our from server input stream. We could draw a flow chart for that. That would be good. All right, let's do our start method. Sure. So I put in my @ override, and I'm going to create my start method. Now in this one, we've got to create a little bit of different GUI items. So let's create a border pane, and we'll call it pane for text field. How's that for a nice short name? Right now, it's just going to be an empty border pane. Now we're going to build up that pane for text fields. So we're going to set our padding. New insets 5, 5, 5, 5. And of course, then I lost that import, which I haven't lost in a while. Make sure you don't get the AWT one. Now I want to add even more properties to my pane for text field. I want to use the set style method, and I'm going to do FX border color. They really like green. One more. We're going to set left a new label, and it's just going to say enter a radius. So on our client side, we'll be typing in that number and then sending it to the server to calculate the radius of the circle. Okay, so that sets up our input. Let's create a text field named TF. And we're going to set its alignment. Set alignment to be at the bottom right. We're going to add that to our pane for text field and put it in the center. I really think we should stop there. I'm going to save this and we'll finish. I was hoping we could do both our server and our client today, but I think it'll just run you guys too short. I want you to have at least close to an hour to work in your groups. So let's stop there and we'll finish this up next time so you can work in your groups.
Could you scroll down so I can just capital on the
Sure. Do you want, which one do you want? That's it? Got it? Great. We'll fix it up next time. We're just not close enough.